ACR9000 hardware uses a 32-bit floating point digital signal processor capable of 150 million flops, or full word-size floating point operations per second. PCs are clocked at gigahertz, but this is for reading-writing 1-bit, not as relevant as doing floating point math for motion calculations, which are done as 64-bit. This high-speed processor means no compiled moves. The 9000 has 1 megabit of user memory. You can have 2, 4, 6, or 8 axis models, and each axis can be servo or stepper. At the top of the ACR9000 you have the axis LEDs, then the 9-pin D-sub auxiliary encoder connector, then the 26-pin high-density D-sub axis connectors. Then there's two 25-pin D-sub connectors for onboard optically isolated 5 to 24 volt DC I/O, which has 12 discrete inputs, 8 high-speed inputs, and 4 outputs. The 9000 has a standard 120 volt AC input plug but uses a universal power supply that can also take up to 240. Next, at the top right, we have the TCP/IP Ethernet port, and just below the USB port followed by the 9-pin CAN open port. There is an indicator LED showing the CAN open network has started. Towards the bottom is the RS-232/485 serial port. The motion enable input can be activated with 5 to 24 volts from the machine controller. An indicator LED shows if the 9000 is receiving power. The AC power input has a 2.5 amp time delay fuse, so an external fuse is not required. It's panel mount design and has standard agency approvals for both CE and UL. As a note on the enable input, this needs to be externally powered. This can be used as an emergency stop, immediately killing all motion. Motion cannot be resumed until power is reapplied to the enable, and the axis kill all motion request flags are cleared, typically in the error recovery program. With both a plus and minus, it can be wired syncing or sourcing, compatible with NPN or PNP outputs. The axis LEDs indicate if they are off, meaning the axis is disabled with no fault. If it is red, the axis is faulted and motion is disabled. Green indicates the axis is enabled and no fault. The serial port is always included with the ACR9000. It supports up to 38400 bits per second and can be used with RS-232 or 485. The 232 is used with a null modem crossover cable. The Ethernet port auto-detects at 10 or 100 megabits per second with standard green and yellow LEDs indicating network traffic. The port auto-detects if the connected cable is straight through or crossover. You can have 4 connections to the ACR9000 Ethernet port, so you could have an express panel connected to it, in addition to a PC connected for SCADA, and also a Parker factory display, plus also be able to connect with a laptop PC for online monitoring with ACR-View. The USB port is 2.0 and it is self-powered. The CAN open is used for Parker I/O for up to 4 slave nodes and has full network isolation. What types of I/O can you use? The Parker I/O is a modular design with cage clamp for easy connectivity and vibration resistance. It supports 1024 bits and can be used for up to 512 discrete inputs and 512 discrete outputs, or 32 analog inputs and 32 analog outputs, or mix and match as need be. Each discrete I/O is 1 bit and each analog I/O is 16 bits. The ACR9000 can communicate up to 4 node modules, so these can be placed anywhere on the machine closer to your sensors. Different modules can be combined and each has optical isolation. The entire module is DIN rail mountable and compact design. The standard cable to connect to the ACR9000 includes a terminating resistor for the CAN bus. The standard PIO337 has the 24 volt supply built into the bus coupler and only needs the PIO600 in module in addition to the I/O modules. The Acano PIO347 does not include a 24 volt supply and would need the PIO602 supply module in addition to the N module and the I/O modules. The Actus connectors can be used to connect to servos or steppers. It has 5 volt DC output for powering encoders and drive I/O. It can output up to 6.25 MHz for step-in direction outputs and has 16-bit DAC outputs. There's the enable output, reset output, and fault input. These can be polarity switched in the software. such as for a stepper axis, it's typically a normally open shutdown input, where a servo has a normally closed enable input. Drive Talk allows for the ACR9000 to communicate via RS-45 2-wire to Aries analog drives. This allows the user one connection to the controller without needing to power down, connect to an Aries dongle inline to the command cable, power up just to see a specific amplifier information. For closed-loop servo control, obviously you have encoder feedback inputs on these connectors. These can be set for standard quadrature, step and direction, clockwise, counterclockwise, or used with SSI encoders. The auxiliary encoder input can also be used with these same types of encoders, and the circuitry is identical, including both quadrature and SSI. A VM26-PM screw terminal breakout module are available and include a 2-foot or 600mm length cable and are DIN rail mountable. Cables are available for most Parker drives. See our Parker System Solution Finder software. It's a free download on our website. The general purpose I/O are 25-pin D-sub connectors. For 2 and 4 axis 9000s, there are 2 of these D-subs. The first has 12 general purpose discrete inputs, and the second 8 triggers for position capture and 4 discrete outputs. If not using those high-speed triggers, you can still use them as general inputs. For 6 and 8 axis, there's double the I/O with 4 D-subs instead of 2, with 24 general inputs, 16 trigger inputs, and 8 outputs. A VM25-MC-02 module is a screw terminal breakout module that includes a 2-foot or 600mm cable and are DIN rail mountable. The general purpose I/O are optically isolated and can take 5 to 24 volt DC sensors with 6.3 to 15 milliamp load. With each point having both plus and minus, they can be used with NPN or PNP. Current has to flow into the plus and out the minus. So for NPN wiring, such as with the Parker 400XR screw-driven precision tables, the plus on the inputs would be pulled high to 24 volts. Then the sensor wire would be connected to the minus on the input. The sensor's common would be connected to the reference on the power supply. So when the sensor was activated, current flows from the power supply into the plus, out the minus, and is switched at the sensor to common. In this arrangement, the ACR9000 input is sourcing the current and the sensor is syncing the current to common and is NPN. For PUD wiring of the 400XR to the ACR9000, the sensor is pulled high. The power supply common is tied to the sensor common and the minus on the 9000 input. The sensor output is connected to the plus on the 9000 input. When the sensor is activated, current flows from the supply to the sensor, from its output into the 9000 input plus and out the minus to common. In this arrangement, the sensor is sourcing and the input is syncing, and this is PNP. The Aries CE and PE are similar circuits, but different pinouts. See its quick reference guide. Online, these connections are shown for the 400XR and LXR, and ETH and I-force and RIP positioners. For the Parker 400XR, LXR, and ET limit switch wiring to the 9000, from our website, go to Supports and Downloads, download application samples and CAD files. Under ACR series support and sample files, if you scroll down to the application notes section, you will see the limit and home wiring. And this gives the color codes and to which pins to connect to the ACR9000. Or the onboard I/O for the For the Aries CE PE limit wiring, the schematic's the same, but the pinout's slightly different. Under the application notes as well too, it's right here. And then you can see the pinouts and which color codes go to where, as well as your power wiring. For the iForce and RIP series positioners which come with flying leads, on the home page go to Linear Servo Motors and then click on any of the motors or positioner pages. And then on the right hand side you'll see that there's applications notes with Trilogy with ACR9000 wiring or Trilogy with ACR PE, CE, and 9040. These applications notes have step-by-step instructions for configuring to the ACR drives and wiring. For the limit switches, which are on page 1, you can see the connections for the color codes and the pinout, and then also the wiring. If you go to the second page, it'll have the encoder, Halls, temperature, wiring, and the pins that they go to, as well as their function. The analog input option supplies 8 single-ended 12-bit inputs, or 4 differential. These can be used to monitor external devices or for closing the servo control loops. Since the card connects to the control board where the EPL card, this option is not compatible with the EPL controller. The battery-backed RAM option allows retaining user variables and is standard on EPL controllers, optional on 9000 controllers. For teach-style applications, it would require this option. Another helpful document is the ACR memory document. From the home page, go to Support and Send Downloads, download application sample and CAD files. Under the ACR series, go down to the Applications Notes, and there is an ACR memory document that explains how to save programs and variables and how it works with the flash memory versus the battery-backed RAM option, and then also with the ACR CE. The ACR9030 is the same as the ACR9000 with the addition of the Ethernet Powerlink, which has the dual ports and EPL indicator LED. This LED will be green after the EPL network is started, and if there is any network fault, it will turn red. It has the battery-backed RAM memory and an option for the CAN-open I/O. The ACR9040 is a slim 9000 with the Ethernet Powerlink. It's powered from 24 volts and also has the motion enable input. It comes with the battery-backed RAM and the serial communication Ethernet and USB ports, and has an option for the CAN-open I/O. The ACR9000 has many different configurations possible to allow users to leverage different motor, drive, and controller options for their applications. Parker motors have a smart encoder option, which is the Q encoder option on the BE and SM series motors, and the 3E option on the MPP MPJ series motors. On power up, the motor sends to the ACRs its motor information in terms of the continuous and peak currents, voltage constant, encoder resolution, etc. This is done via 2-wire RS-45 on 2 of the Hall sensors in the standard feedback cable. This is done every time on power up or reset. So if you change the drive, it'll automatically configure the new ACRs drive for the motor, saving the time to connect with the ACR Support Tool software and dongle to tell it what motor is connected to the drive. After this power-up sequence, which only takes milliseconds, ACR9000 can enable the ACRs and runs the motor the same as a standard motor, outputting an analog command signal and reading back the encoder quadrature position. With the ACR9000 with analog ACRs drives, the ACRs also supports INDAT absolute encoders. So on power up, the INDAT tells the ACRs drive where it is, eliminating the time for homing and limit sensors. A little known fact, the MPP MPJ series motors with the INDAT are also smart encoders, telling that base ACRs amplifiers what motor is connected. With the analog command cables connected to the ACR9000, it uses the SSI encoder input to retrieve the absolute encoder position. Here's a different configuration with EPL. A 9040 is connected via Ethernet IP to an express panel. The ACR PE drive is driving an MPP MPJ motor with a 7D multi-turn INDAT absolute encoder with 19-bit resolution. That's 524,288 counts per rev and 4096 turns. The second ACR PE is driving a BE motor with standard incremental J encoder. On this part of the machine, it could be acquiring the line speed with a quadrature encoder, which is updated across the EPL to the controller. Also connected are three Compax 3 i30 drives. The first with F11 option is driving an MPP MPJ with 6S multi-turn Stegmann hyperface absolute encoder. 16-bit resolution over one turn is 65,536 counts per turn, 4096 turns. The second with F12 option is driving a Trilogy linear servo motor with incremental encoder. This could be connected to an SSI or quadrature encoder line speed encoder connected to the X11 connector. The third with the F12 option is driving a BE servo motor with incremental J encoder connected to a precision screw-driven 400XR stage with load-mounted linear encoder, which would be wired into the X11 connector and configured as a load-mounted encoder. With the 9030, you can have the Actus connectors driving stepper axis, such as the EAC or EDC microstepping drives with LV-HV step motors. Another Actus could be a high-accuracy inspection unit with the Dynaserve direct drive rotary servo. In addition to the analog and stepper Actus, this shows three Aries PE drives that could be 100 meters between each unit connected via Cat5 cables on the machine, plus a multi-axis Compax 3M EPL. These are just a few different examples of the possible configurations for ACR9000, ACR9040, and 9030. The ACR9000 series controllers can also communicate Ethernet IP to Rockwell Allen Bradley Compact Logics and Control Logics PLCs with SIP Class 1 UDP and Class 3 TCP messages. With Ethernet IP, the ACR9000 can be the high-performance motion solution for a PLC-based machine. This slide shows a centralized architecture. Or for a distributed architecture, the same level of performance with a modular machine layout. The ACR9000 series controllers uses the ACR-View software. It ships with each controller and is a free download on our website. The configuration wizard is Windows menu driven and guides users step by step through complete controller configuration. The ACR9000 has full documentation from the hardware installation guides and quick references to the programmer's guide, command reference, and bit parameter reference. This information is available as PDF on our website and also in the ACR-View online help, making it easier to search. For advanced applications with users developing their own PC interface to the ACR9000, the COM ACR Server 6 user guide covers the communication server, which is installed when you install ACR-View and is what ACR-View uses to upload and download to the controllers. For communicating to Rockwell Allen Bradley Compact Logics or Control Logics PLCs, the Ethernet IP user guide shows step-by-step instructions for how to set RS Logix software with screen capture. In ACR-View, go into Help, User Guides. You'll see the Programmer's Guide is the first section, covering the programming basics, basic setup, making motion. Set point summation is discussed in the servo loop fundamentals, and then also application examples including enabling the drives and the EPL network. Under the reference guides, you'll see the User Guide 1 is the parameter reference, and then also the bit reference as well too. And then there's an entire section dedicated to the Aries controller for the parameters, since that's a little bit different product, being a drive and controller altogether. If you click on the Search tab, if you happen to know which parameter that you're looking for, don't include the P at the beginning of the number, but just type in the number. 8193 is the vector velocity. You can see the search results are highlighted on the page. This is the vector velocity for master 0, so if I had multiple axes, this is the interpolated velocity between all the axes. And then if I scroll down further along the page, it gives a further description of all the parameters. At the top, you can see with 8193, this is the vector velocity for master 0. If I was looking for the vector velocity for master 1, that would be 8449. and etc. If I don't know the parameter, if you just go into the search, just type in the name, invert motion, and see under axis 0, if I scroll down and see the invert motion direction is 8455 for axis 0. And if I want a further description, just scroll down towards the bottom and I can see invert motion direction reverses the direction on the axis. These user guides are also available on our website. If you go to Literature on the top right hand corner, then click on User Guides and ACR Family, you'll see the ACR9000 Hardware and Installation Guides, as well as the General Programming, which has the Programmer's Guide, the Command Reference, Parameter and Bit Reference, and the latest documentation. This completes the ACR9000 hardware presentation. Key points to remember are 1. The controller and drive part numbers show the hardware options. 2. Ethernet Powerlink is a motion bus that is high performance, increases reliability, and saves in cable costs. 3. Numerous features allow system flexibility for customers' most demanding applications.